5, question number 12 of application of derivatives. Show that the semi-vertical angle of a right circular cone of given surface area and maximum volume is sine inverse 1 by 3. You need to prove that the semi-vertical angle of a cone is sine inverse 1 by 3 when the surface area is a constant because it's given, but volume to be maximized when the volume is maximum. How does a cone look like? A cone look like this. What is the cross section of a cone? Cross section of a cone is an isosceles triangle, right? It's an isosceles triangle. So the vertical angle is this. So this is what we need to prove. Not this one, semi-vertical angle. How you make it semi? You just have to draw the height. Then it will be half. So let me name this as theta. I need to prove theta equal to sine inverse 1 by 3. To prove theta equal to sine inverse 1 by 3, first thing I need to, our function is volume. Volume is 1 by 3 pi r square h. We need to differentiate this. But when I try to differentiate, I have two variables. R is also a variable, h is also a variable. How to get rid of? You need to convert one to the other. For that, who will help you? The given thing. What is given? The surface area. The total surface area is a constant thing. So to write total surface area, I need a radius also. So this is radius, height, slant height. So surface area, we'll start here. Surface area is a constant. What is surface area? Pi RL, that is a curved surface area, plus pi r square, that is the bottom, the base circle is equal to a constant. Now L we don't want at all in this. So I will remove that L. How do I remove L? By Pythagoras theorem, L can be written as root of h square plus r square plus pi r square is equal to k. From here, I can find either h or r. I want to find h. So I will write this as root of h square plus r square is equal to k minus this pi r square to that side minus pi r square divided by this pi r I have to divide. Now h is not free to find out. Here h is under square root. So I will square on both sides. Then I will get h square plus r square is equal to k minus pi r square the whole square by pi square r square. Now h square will be equal to k minus this, let me expand this, k square minus 2 pi r square k plus pi square r power 4 by pi square r square minus r square. What I did? I expanded the numerator a square minus 2ab plus b square by the denominator. This plus r square I took to the other side minus r square. Now let me take LCM. So k square minus 2 pi r square k plus pi square r power 4 minus, when you take LCM it will become pi square r power 4 by pi square r square. This gets cancelled. Now only left is this thing. So h will be h square, let me write, h square is equal to k square minus 2k pi r square divided by pi square r square. Children, I want to substitute here h, but I have h square here. If I write h, I will get a square root here, square root of, then differentiation will become complicated. We have one option. You just square the function and you can differentiate. Still the answer will be same. So you can do that. So if you write v square is equal to 1 by 9 pi square r power 4 h square. This equation number 1, I will substitute this 2. When you substitute, so I will get v square is equal to 1 by 9 pi square r power 4. In the place of h square, I will put k square minus 2k pi r square by pi square r square. Pi square cancels, r square and r power 4 cancel, you get here like this. So this will become 1 by 9. Let me multiply this inside. When you multiply this r square inside, you will get k square r square minus 2k pi r power 4, right? That's all. This completely gone. Here r square is gone. So denominator nothing other than this 9. Now we will differentiate. So d of v square by d with the only variable present is r. K is a constant, pi is constant. So with respect to r. So this is equal to 1 by 9. This will become r square derivative 2r. So 2k square r minus, when you differentiate this, it will become 8k pi r cube. This is what we need to equate to 0. This first derivative only we need to equate to 0. 1 by 9 is not 0. So the only possibility is this part to be 0. If it is equal to 0, I can write 2k square r will be equal to 8k pi r cube. When you equate to 0 and take to the other side, you get like this. So you will get 1k cancelled, 1r cancelled, and 2 and 8 cancel, you get 4. So ultimately, I get k is equal to 4 pi. Here 1r cancel, here you will have r cube, it will become r square. So this is what I am going to write as my critical point. This where to substitute? I will substitute it in the first function, first equation, this equation. Already I put here 1 and 2. So this equation I will put. So let me substitute it over here. Okay, now what I do is I will substitute it over there. So let me remove this one. So we get, what we get is, when you substitute it here, I will get pi RL plus pi r square is equal to what? This k is 4 pi r square. K is 4 pi r square. So I substitute k equal to 4 pi r square, which is my critical point after differentiation, that I substitute it in this first equation. Now you take to that side, you will get a pi RL is equal to pi r square. When you subtract from 4 pi r square, it will become 3 pi r square. Now what we can cancel? We can cancel this pi. We can cancel 1 r. So I get L is equal to 3r. Now L is 3r. Let us come back to this. Come back to the figure. What is the figure? This is the figure. In this figure, in the place of L, I will put 3r. Because I proved L is 3r. Now you find this theta. Or you consider sine theta. What is sine theta here? Sine theta is opposite side. Opposite is r. By the hypotenuse is 3r. So r and r cancel. I get 1 by 3. So theta will be sine inverse 1 by 3. So we proved that semi-vertical angle is sine inverse 1 by 3. One part is left. What is that? We need to prove the second derivative is negative. For that, I will differentiate this equation. I have to differentiate one more time. If I differentiate that one more time, then I will be able to say the second part. So I am going to differentiate that. See. Okay, so I will get this. I am differentiated. D square of v square by dr square, which is, when you differentiate, you get here 1 by 9. Differentiation of this one is 2k square. With respect to r, it will become 1 minus, here r cube will become 3r square. So that will be minus 24, 3 into 8, 24 k pi r square. This happens at what? K equal to 4 pi r square. So in the place of k, I will put 4 pi r square. So this will become 1 by 9 2k square. What is k square? Then it will be 16 pi square r power 4. K square r power 4 minus 24, and in the place of k, I will put here 4 pi r square. So into 4 pi r square, again pi r square. Okay, this will become 1 by 9 This is 32 pi square r power 4 minus, this will be 96 pi square r power 4. Children, look, both are like terms. Pi square r power 4, pi square r power 4. So when you subtract 32 minus 96 is negative. The rest all are positive. Pi square is positive, r power 4, 1 by 9, everything is positive. But here when you subtract, you get, so this is less than 0. So we will say what we found, k value, k equal to 4 pi r square, or our theta equal to sine inverse minus 1 by 3 is maxima. Maximus semi-vertical angle, only that. Okay, good. Keep looking at it again and we will get it.